Our geometry, we're finishing up this packet with the congruent triangles extension problem. Alright, so example 1, it gives us a congruence notation statement, right? And it tells us to solve for x. Alright, so if the triangles are congruent, what must be true? Remember, two things are true if triangles are congruent. Number 1, all corresponding sides are equal. And number 2, all corresponding angles are equal. Okay. So looking at this, it's telling me to solve for x. And it looks like I have expressions for the angles. Well, looking at the congruent statement, I know that angle L is congruent with angle x. So, corresponding, L corresponds with x. So I know that these two angles must be equal. Well, if they're equal, I can set them equal to each other. 6x is equal to 3x plus 15. That's angle L, this is angle x. We set them equal, and now we have a simple algebra problem. Alright, so we want to solve for x, so we need to get x by itself on one side. So I'm going to move the 3x by subtracting. I'm going to subtract 3x from both sides. So 6x minus 3x gets me 3x, and the only thing I have left over here is 15. So I'm just going to bring that down. A coefficient and a variable together like this are multiplication. So the opposite, or the inverse of multiplication, is division. So to get rid of that coefficient of 3, I'm going to divide both sides by 3. So that's going to leave me with x is equal to 5. What an ugly 5. X is equal to 5. 15 divided by 3 gives me 5. So it asked me to solve for x, and I did that knowing that corresponding parts of congruent triangles are congruent. Alright. Next up. Which correspondences are equivalent to triangle LMN is congruent to triangle RST? Alright, so it looks like we know what letters go together, right? We just need to figure out which one of these are equivalent. So let's start off by the first thing. We know that if two triangles are congruent, number 1, all corresponding sides are equal. Yes, you must write this out. Writing it out will help you remember. All corresponding sides are equal. And number 2, all corresponding angles are equal. Alright, so looking at this congruent statement, I know that angle L is equal to angle R. They're both the very first letter, angle L and angle R. I know that angle M is congruent to angle S, because those are the next two letters. And I know that angle N is congruent to angle T. So knowing this, because of my two things I know about all congruent triangles, this means I can find out which congruent statement is true. Alright, so let's compare. This one has M and S as the first letter. Does M equal S? Yes, it does. Alright, for the middle letter, it has N and T as being congruent. That's also true. And the last letter, L and R. Okay, that's true as well. So this one works. Let's keep going and see if this one does as well. Is L and R congruent? Yes. Are N and T congruent? Yes. Are M and S congruent? Yes. So lucky us, A is the right answer. Let's go ahead and disprove B. So B, are M and S congruent? Yes. Are L and R? They are. R. N and T? Alright, so this one works. Let's look at this one. Are N and S congruent? No. N should be going with T. So this one doesn't work, that's why B is not my answer. Alright, let's look at C. Are M and T congruent? No. M and S are congruent, so that doesn't work. So I can eliminate C. Alright, what about N and R? No, N and T are congruent, so this doesn't work either. So all we're doing is matching up the letters to see what congruent statement is the same. A works. A is our answer. All right, example 3. Triangle JKM is congruent to triangle QPR. All right, so if two triangles are congruent, what must be true? Number 1, all corresponding sides are equal. And number 2, all corresponding angles are equal. All right. So it tells us that JM is 3, tells us that MK is 4, and KJ is 6. And then it asks us for the length of RP. So we're looking for this length right here. So I need to figure out what goes with P and what goes with R, so we can figure out what the length is. All right, so looking at this, P is the last letter in my congruent statement here, so it must go with K. All right, so K is right there. R is my middle letter, so it must go with M. All right, so looking at this, it looks like KM is equal to PR. So if KM is equal to PR and KM is 4, that must mean that RP or PR, we can write it either way. I wrote PR here, but it can be RP, that's fine. That means that must also be equal to 4. So 4 is my answer. So you might have gotten thrown off because you were just looking at it and it looked like a reflection, but remember we have to go by the notation in the congruent statement. All right. Example 4. Is triangle ABC congruent to triangle DEF? Explain. All right, this should look familiar to you. This should look like a transformation that we've done before. So remember our 4 transformations. We have reflections, rotations, translations, and dilations. Out of these 4, what do you think happened here? Let's say this was the pre-image and this was the image. What happened? What occurred? All right, I hope you said translation, because if we actually count from point to point, see how A corresponds with D, and all we did was move A 1, 2, 3, 4 to the right. B, we moved 1, 2, 3, 4 to the right, and C, we moved 1, 2, 3, 4 to the right. So we actually had a translation, 4 to the right, and 0 up or down. So yes, the 2 triangles are congruent. Because triangle ABC was translated 4 units right to map onto triangle DEF. Translations are rigid transformations. Which means the pre-image and image are congruent. All right, I know that was a lot, but basically that's what a rigid transformation means. Remember, reflections are rigid, rotations are rigid, and translations are rigid. The only thing that's non-rigid are dilations. So we could not say that a dilation would result in a congruent pre-image and image. But since it was a translation, we could say these 2 triangles are congruent because translations are rigid. All right, the last one. Is rectangle ABCD congruent to rectangle PQRS? So look what we did. We translated 5 units down, and then we rotated 90 degrees clockwise. So we had a translation, and we had a rotation. So what do you think? Are the two rectangles congruent, the pre-image and the image? All right, I hope you said yes. Yes, the two rectangles are congruent. The transformations that occurred are rigid. So the pre-image and image figures are congruent. If we had a dilation happen, then we cannot say that they would be congruent. But since it was a translation and a rotation, yes, the pre-image and the image are congruent. All right, let's go ahead and fill in the blank of these main ideas. So rigid transformations create figures that are both similar and congruent. Remember, if something is congruent, it's automatically similar. Dilations create figures that are blank only. I hope you said similar only. All right, congruent triangles have two things in common. All corresponding sides are equal. All corresponding angles are equal. All translations, reflections, and rotations are rigid transformations that create blank and blank figures. So we're going to say similar and congruent, because if something is congruent, it's automatically similar. So the pre-image and the image have equal corresponding angles and equal corresponding sides, right? That's what we just set up here in 3A and 3B. All right. If you can translate, reflect, or rotate a figure back onto itself, then the shape is similar and congruent. Remember, these are our three rigid transformations, so we know that rigid transformations result in congruent pre-images and images. If it were a dilation, it would be similar only. Great work.